Okay, here we go. Manuela, did you see this? You saw this posted to Rhino? Sorry, posted to Canvas? Sliced it up for you. What do you think? We couldn't, this piece is not going to, I'm not assigning that to anybody.
I'll take that one.
I had to add a few, like this one is not really going to pan out either. We'll see how it goes. Because it doesn't hit two pieces. But before this one didn't hit two, so I slid this rib over. There's some other, like this one at least is hitting this and this, so it should be fine. So, you know, we're just going to have to see how it goes with this. Obviously, if we just kept adding pieces and, you know, adding slices, it would, at a certain point, become solid. But the efficiency of building things this way is that, you know, you just section it up and then deal with flat pieces. It's going to be nice, I think, the slices on the back are going to work well with the design. And obviously, you know, we could have done like some of the things we saw in Slicer where we slice it like concentrically. Yeah, we could do like a polar array and slice it so all the slices are rotating. But we're not going to do that in this case. Okay, we're just going to go like that. And click. Look, if you click through and click on properties, you'll see this is layer 15, layer 13, layer 14, 12, 11, 10. And then I think these are like 65, 66, 67, 68, 69. There are 69 people enrolled in the class. There were 87 at the beginning of the semester.
How many people have dropped in general?
Well, 69 minus 87 is like 18 people. 18? Oh, from the studio? I don't know.
We're all in the studio.
Yeah, quite a few have dropped from each section. Okay. So, let me show you what to do. So, say your name is Aerosol and you get layer 19. You got to do this one. I would copy this over. Okay, look what we're going to do. All right. Planar surface. All right, we need to see what this piece intersects. So it's going to intersect these cross grains. So I'm going to do a planar surface on each of these, just so we can illustrate. There it is. Yeah. So her part intersects these three pieces. So I'm going to select these three pieces. This is what you'll need to do. And I'm going to hide them. Delete all this. I'm going to unhide. All right, so this is your part. Yeah. How thick is the plywood we're getting? How thick is plywood, generally? What? 3/4 of an inch. Standard ply. What is plywood primarily used for? What? Yeah. Usually it's, one of its biggest uses is for subflooring. So you'll have ribs called floor joists, kind of like this. You'll put down subflooring as 3/4 plywood. You'll nail it into the joist. Then on top of that, you'll put hardwood, finished floor. So the plywood underneath is usually not a very high quality. You know, they use it for cabinets and things like that. But typically, like construction grade plywood is 3/4 of an inch. And if you had a wall, for instance, where you're going to hang art, I don't know if you guys have ever tried to hang a large picture on just a sheet of drywall. You know, you hammer a nail on the drywall, it just comes out. So if you're when you guys are designing galleries in the future, in your drawings, you'll put continuous blocking, plywood blocking. So you have a whole layer of plywood behind the sheetrock, so you can nail into it. It stays there. It doesn't fall out. All right, but they don't ordinarily do that. All right, so here we go. Look how great. This is going to be fun. All right. So what I'm going to say is, yes, we will intersect, but we need to, I want to show you two things that the machine is going to do as it carves out the intersections. And so, yeah, let's start with intersect, but let's establish a rule. If you have one of these cross-grain members, which most of you will, let's notch out from the bottom. Okay. So, yeah, let's just do a quick intersection. No. That was Monday's news. This bench is going to be a lot better than that, by the way. All right, so we've got our intersection lines. I don't need this anymore, so I'm just going to duplicate the boundary of it and then delete it. Okay? So here's my 3 intersections. I'm going to make this one blue, make the interior ones red. By the way, Manuela did something that McNeil has not been able to get me to do for the last 2 years. She sent me a Rhino 6 file, so I downloaded the trial version of Rhino 6. So that's what I'm using now. All right. So all we need to do, guys, is go to the midpoint. Yeah, we're going to go to the midpoint. Let's just locate the midpoint. All right, so we're going to locate the midpoint. I'm going to come in here. I'm just drawing a line at the midpoint. I'm going to move this over, intersecting at the midpoint. And we said we're going to notch out of the bottom, yeah? I like to copy as I go. So we're going to trim. These are going to be our trim. Oops. Okay. We're almost done. We're going to rotate this flat. I'm going to rotate this 90 degrees. All right, I'm going to do this for now just so it's perpendicular to the vertical of our cuts. So what's the next thing we need to do? You need to offset this for the thickness of the material. So 1/2 of 3/4 is 3/8. Yeah? So we're going to go 3/8 on either side. Our type distance, 3/8. Is that right? Let's measure it. Yeah, there we go. Okay, so we're going to offset again. I'm going to tell you right now, guys, it's kind of a pleasure the last day when you all show up with these parts and we just snap the whole thing together. Some of your pieces are going to go together with ease. Some of you are going to be like hammering them because they're too tight. And some of you are going to cut these in the wrong place, and everybody else is going to be like, it's going to be really disappointing. So just do this correctly, okay? You saw how easy it is. It's not much more than that. So let's make sure we do a few things. One, we want to extend these lines all the way to the boundary. So you know how to use the command extend. Okay? Now we can go through and just trim everything. Okay, so we don't need this anymore. Right? We need to trim these. Delete. Delete. Join. Are we done? No. Let me talk to you about dog bones and T-bones. You know what I'm talking about, Jonathan? All right. Okay, so here it is. Did I talk to you about this already?
No.
It was last year. I'm having flashbacks. All right. So how does the CNC mill cut? The laser, the cut, it's not using a tool, it's using a laser. It has very little thickness, right? It has some. It's laser sharp, but it's still got some thickness. Meaning when the laser hits the material, some of the material is being lost, but not much, maybe like 1/100 of an inch, something like that. But the CNC milling machine is basically, let me show you what it's going to do. We're going to offset this. It's using an end mill, right? Not a drill bit, an end mill. Did I show you end mills on McMaster car? Did I? You sure? You want to see it again? No. Okay. It's pretty cool. All right. Let's copy this. McMaster car. I showed you this? No, I didn't show you this. Did I really? This is an online website. This is great. By the way, guys, you go to screws. So later, if you're drawing detailed sections, we're not yet drawing screws and bolts. But often you'll actually coordinate even the size of the material down to the screw. So if you come into McMaster car, say I want to get a carriage bolt. The carriage bolt is a flange with a square head, so that it means you don't have to hold it with pliers. You just insert it into a square cutout, and then you can just tighten the bolt, and it doesn't rotate. So, but say you want a medium neck grade 5 steel square neck carriage bolt. You're going to come here and pick this one. All right. They cost $10 for a pack of 50. Go to product details, and usually this one doesn't seem to have it. Let's try another one. Okay, check it out. Product detail CAD. So you can download a 3D model of the screw. You can get it in CAD, a 2D DWG. Right? You could actually download these and 3D print them if you want. What's that? Yeah, because they want you to put it in your drawings, basically. Right? I mean, you couldn't 3D print the screw and use it as a screw. It's not going to be strong enough. But they want you to, put it in your Revit models, put it in your CAD files. So, basically, the way the machine works, the CNC milling machine works, you're going to be using something like this. Right? So you're probably going to be using the shop has square end mills. You can get V-bits where they're like chamfered at the end. You can get router bits that round over, so you can like round over the corner. So you see how all these things work. But you'll most likely be using a square end mill. Ball end mills, if you're doing like contours, you can, because each one, as you cut and it lifts, you're going to get a kind of like stepping, almost like a topo map. So the ball end, you have like a much smoother stepping. But you're probably going to be using this, and there's upturn and downturn. You're probably going to be using a fast-cutting rough carbide square end mill. And so, how big is this thing? So we need to know how big it is. You're probably going to be using probably a 1/2 inch. Probably going to be using a 1/2 inch bit. Let's assume it's 1/2 inch. There are smaller ones. The thing is, the smaller it is, you need to run the machine slower. So what it's doing is it's plunging into the material like that, and then it's moving this way. And you don't want to plunge too much. If you plunge too much, you're just going to break it off. So usually you don't want to go deeper than the width of the tool. So if it's a 1/2 inch, you don't want to go down more than a 1/2 inch. And So if it's a 1/4 inch, you don't want to go more than a 1/4 inch. So you can cut it faster with a wider tool. And again, even if you go down, the width of the material, you don't want to move it too fast or you'll break it off because it's all this side pressure on it. Anyway, so let's assume we're going to use a 1/2 inch. Yeah. Certainly, yeah. So this one doesn't have usually you could download parts for a lot of these things, but we know it's a 1/2 inch. So back in Rhino, what we need to do is offset this, and the distance, we're going to say, let's start with 1/2 inch, and then let's say 0.25 of an inch. Okay? So this is the midpoint of my end mill, right? So if I draw a circle, and I'm going to make the radius 0.25. You see what's happening? So this thing is traveling along this path. It's called the tool path. All right? So it's going to travel along this tool path. You see it's cutting as it goes. Let's make this dash. All right, it's following the tool path. It's cutting as it goes. What happens when it gets here? It's going to leave this. It's going to leave this. And it's going to be a problem when you go to put the other one in. They're not going to fit tight. So you don't want to leave that. So what do we got to do?
Don't we make it?
Make a dog bone.
What?
Oh yeah.
So when you get to this point, you want to go over to the side a little bit. So you notch that out. So you're going to take this, and you're going to go to here. Okay? So you're going to get all that material. You're going to clear it out. You're going to cut a little extra, but that's okay. And then it's going to come back over to here. And then it's going to come back and then go back down. So what this is going to look like, actually that's called a T-bone. Let's do a dog bone. All right, so say here, the other way of doing it, instead of plunging to the side, is to just continue this way.
There's no way to do that edge like precise. No, right?
Yeah. What do you mean?
I mean, if I want that exact shape.
Not with a spinning machine. No. The only way to do it is just use thinner and thinner and mill to the point where, it'll take you much longer to cut it out. But these things, I'll show you some examples of what these look like. I don't think they're. I think they add a little detail to it, and they show kind of evidence of the process. And if done correctly, they can be nice. Okay. So one way is to do it like this. And if these were smaller, you'd get more of say you had something like this. Right, so if it looked like this, that's a dog bone. Okay, so this little spacer is still gonna hold it in place where it's supposed to go, but you just clear away all the excess material. I like these things, so don't let it throw you off. I do think, however, you should go through and actually notch this all out so you have a realistic idea of what it's going to look like. Yeah. So we'll go through. Let's just do it real quick. Take these. Does everybody see why we have to do this?
So you fix the other part.
Yeah, so it doesn't, so it's precise. Okay.
We're doing all of this when they're offset by already.
In the what?
Like all of this is offset by whatever already. Like it's already smaller than it's supposed to be.
It's already smaller? No. What
Like
is it?
you offset it twice.
But you have set it out. So it's
Okay.
speed.
No, I offset just to show the toolpath. And generally, I think you want to go through and do this. Just draw it like that. And then worst case, you're using a smaller tool. So when you go to program it at the shop, basically, you're going to do all the settings in the toolpathing. It's called CAM software. So you're going to open this up. It'll take you not much time at all to prep it. But you're going to say, how big is the end mill? You're going to look, what is it? Is it a 1/2 inch bit? So, worst case, they'll come back, and maybe you're using a 1/4 inch end mill. So you could offset this 0.25. Okay, so that will be your toolpath. So it's still going to cut out something like that. But I would do it just to be safe. Okay. So this is what you should bring with you when you go to the shop. Make sense? Yeah. And then just to verify that we've done it correct. The other thing we need to do, since some of you are going to be sharing boards, it wouldn't be a bad idea if some of you want to lay out a board together. But what I don't want is like Veronica cutting 6 people's parts. Because what happened 2 years ago is people were doing that, and then they weren't labeling other people's parts. They didn't know what they were, and they were just piling them up, and nobody knew what went where. And everybody was in the courtyard with Rhino opening, like looking at their part and looking at the computer. Nobody knew. So you need to cut it. Ideally, you would maybe engrave your name and the part number on it, or just write it on there with a marker right after it cuts. But unidentified parts, we don't know what to do with them. It's like a big jigsaw puzzle. We have like an hour to put this in together. Okay? So, but if you want to share, I would say, lay these things out. Well,
You just put it in colors and say, okay, yours is the green one in the bottom, and the other one is in the middle, and the other one is on top.
but it's not going to come off the piece of plywood in color.
I know, but you already have it in the file, so when you take it out, you just write it.
Right, but what I'm saying is if you're not there to do that, Jonathan's not going to do it for you.
Okay.
Okay? Everybody needs to go and do this. Or what you can do is even if you just lay out your pieces, say these are a couple of different pieces. Oh yeah. They're on different layers.
It's rotating 3D.
Why is it doing that? Hey Rose. How's it going? Alright, so you could really fit quite a few. What's the closest I want to get this to the edge? Probably well, what would limit how close I put this to the edge? How is this held down? You're going to put screws all on the edge. Don't mill off a screw head. Sparks will go flying. A screw head will shoot across the shop. You should be wearing safety goggles, but if you're not, you might catch it in the eye. You're going to shatter the end mill. It costs like $40. So stay safe. I would stay like 1 inch inside the edge if you can, just so there's that much room for screws and you're sure you don't hit them. Yeah?
You just screw it?
Yeah, you're going to screw this down to the CNC milling bed. You're all savvy with drills, I'm sure. Okay, it's going to do something like that. Yeah? And just make sure it's in there. And then let's take this. Let's look at it in 3D. I think it would be nice if you all... Look, let's say write your name and write your part number on it. Okay, this is 3/4 of an inch. So if we extrude, curve, do direction. We'll do B for both. What was it? 3/8 of an inch on either side, right? Why didn't it do solid? Direction.
What was the middle for 3/4 of an inch?
What's that?
What was the middle?
Half of 3/4? 3/8. Yeah? So 3/8 of an inch. Okay? Yes? You type D. Watch. So, extrude curve. So it's going to, so I can either click on the direction up here, or for any of these options, you'll see one of the letters is underlined. So if I type the underlined letter, it'll select that option. Then it'll ask me for the direction. So I'll go that direction. It's solid, yes. Both sides, yes. And then we just type 3/8 of an inch. Alright, so now we can go put this thing back. I'm going to rotate it. Let me do this one real quick to show you what that looks like with the dog bone from the top. All right, let's do this one. Do this real quick. Okay, guys, while I'm doing this, I want to tell you next week, if you want to have Monday as a work day, let's have class Wednesday, and I want to give you a rendering demo so you could render your final projects. Okay?
So this next Monday or Monday after Thanksgiving?
No.
This Monday?
There's no more classes after next week, yeah. No, so this Monday you have a review in studio. So I assume you don't want to come that day.
No.
So we'll come Wednesday. We have our final class. We'll do a rendering demo. Yeah? And then we'll go over the requirements for the final, which are like not a lot. So the cross members, this is the long member. The cross members we notch out of the bottom. So we need to notch out of this one from the top, right? So we'll just find the midpoint.
So if you have one of those, that means that you will have to...
Manuela is going to cut all of these,
Oh.
all the long members. Okay?
They will have like a left.
And then you're going to do all the comb teeth. We're just going to slot in. Okay? So what did we say? We need to trim from the top. Or we want the notch in the top. All right, so we're going to offset it. Again, 3/8 of an inch. Where's our fearless TA, Amanda? All right, we're going to extend this. Make sure we get to the edge. Extend. All right, now we can trim. Now we can join. Now we can T-bone, dog bone. All right, it's going to be a 1/2 inch end mill. 1/2 inch diameter. Did I do something wrong? What?
You don't have to put it on top. You have to put it in the middle.
I can do either one, but how come when I did it on the other one?
It was much bigger.
No, it was the same, but it wasn't on the top. It's because you have set it first. The original one, you did it
Huh.
offset. Then you did that.
So it's 1/2 inch radius with the
You put it on top.
Oh, right. Yeah, if I bumped them in, because it's about to be like that. All right, so let's move these down. Let's trim this.
But basically, we don't have to do the offset that you did at the beginning, right?
I did that just to illustrate
Okay.
how it works. But you need to bring a file like that on a piece of plywood ready to go. And then I would say, I think you should 3D model the pieces that intersect yours and notch them out just to verify they fit. Don't wait till you're assembling it to make sure they fit. But let me show you how this works. So let's do the same thing. Let's extrude curve again.
Are we gonna get like the big piece to put it in the CNC? Of plywood?
What's that?
Are we gonna get the entire piece of plywood? Like the size of the CNC?
Well, plywood. How big is plywood? Yeah, 4 by 8. So you'll get, each of you will get a 4 by 8 piece.
Each one of us, or it's gonna be like the other one?
You need to share. I got 30 sheets of 4 by 8. Did I do the wrong one? I did the wrong one. Oh, no, I didn't. I did the right one. All right, see what it's going to look like? Why can't I zoom in a little? It's nice, right? Okay, another trick. Guys, this is a trick, but you basically need to do this. So it's not really, I would consider this part of the assignment. Here's the thing. Delvis was dealing this. If any of you have the Musashino art library, all those bookshelves that, if you've got all these slots you're trying to put together, often that sharp corner, they get stuck. Yeah? So you probably want to round these over just so they're like a little more leeway and they'll kind of clamp together. So I would type the command that's pronounced fillet. It's not a fish fillet. Okay? And I would just give it like a 1/4 inch or a 1/2 inch radius. Say 1/2 inch. Valerie, are you leaving? Oop. Oh, why is it doing it over there? So, let's fill it. You probably want to do this. Okay? I would do that. All right? Sound good? Brian? There is a little issue I just thought of. Let's see. So I think there's even a dog bone and T-bone option in the slicer program. All right, this should be good. Okay, everybody got it? So that's what you need to do. So, come 3D model these. What do you have to do? I can't hear you. Do this, just to verify they fit together. So when you stand them out, you'll go, whoa, something's wrong. I recommend doing this before you CNC mill it. Now, Manuela is going to notch out all of these notches here. That way, not each of you is like notching one out. We'll help you, Manuela, a little. But I think it'll be important to set these up, and then everybody can just come drop theirs in. Yeah, but that's going to be it. So this is saved on the, I'll update the one that's saved on Canvas so you have this example. And then just go through, and to reiterate, Jonathan, since you weren't listening earlier, if you go click on the bench, you'll see under Properties, right? That says layer, see over here, layer 24, layer 18, layer 11. So you're going to get a roster with your name and a number. You go find that layer. That's, it is on the drive. On what? No. I already did it for you.
Oh, you did?
Yeah. Yeah. Okay? All right? Is everybody good?
Yeah.
All right. I will save and upload this video.